when we talk about the sine law, it is still an equation, just like our SOHCAHTOA, except that it's a little more specific. It can help us to determine either the side across from an angle or an angle across from the side. The biggest thing that we know about the sine law, though, or that we need to know, is that it is not limited to right triangles, which means we can use it for non-right triangles, basically where you don't have a right angle in your triangle. So to determine the side length of an oblique triangle, which can be any kind of slanted triangle, we must first know one side and the angle across from it, known as either as an angle-angle side property. Now, the sine law is usually known as sine A over A equals sine B over B, or it can be done the exact same way as A over sine A equaling B over sine B. So because in Foundations 20 we do a lot of proving, we're going to actually prove this as an exercise in Foundations 20. So actually, before I even do that, let's label this triangle. So yes, we can see that this looks like a right angle triangle. It doesn't really matter. I can have this completely tilted off. So this side could be right here. It's still going to work out. So let's label it C, B, A like that. So if by chance this was like a 89-degree angle, yes, it's not a right angle, what we can do, no matter what, if you draw a line straight down, you would be able to create two right triangles. One thing I know I neglected in the first section is talking about what sides and angles are actually labeled as. For example, the side across from A is going to be a lowercase a, the side across from B is going to be a lowercase b, and the side across from C is going to be a lowercase c. Now obviously this has been split into two things, but it still is the entire side C. Lowercase letters typically indicate sides, uppercase letters are for angles. So I'm just going to write that down. So in order for us to prove this, the beautiful thing is because we have two right triangles and we have actually one side that's common, we tie this back to kind of what we've done in Foundations 10, where we have the height here. The extension on it is we can have what our height is in relation to this angle, to angle B. So this side would be our opposite side, and this would still be our hypotenuse. So if we had the sine of B, it would equal h divided by a. At the same time, in this triangle over here, we can say that the sine of A, so this angle, would still be our height divided by the hypotenuse of this literally right triangle. So if we solve both of these equations for h by multiplying this one by a on both sides, and this one we have to multiply by b on both sides, we'd have it that h on the left-hand side would be a multiplied by a sine of b, and on this side, h would be b multiplied by the sine of a. So this comes into effect of why it's so important to know how to solve equations, because if we have both of them equal to h, that means that they must be equal to each other. Then we can do some work. For example, I can divide both sides here by a. What do we got? I'll use the purple. A's would cancel off. So the sine of B would be B sine A over A. And if we divide both sides by B, oh, don't know what happened there. Give that a look. And I'll stick with the green. Divide this one by B, divide this one by B. B's cancel off. So the sine of B divided by B will be the sine of A divided by A, which is exactly what our law states. And all it is saying that if we have this angle and this side across from it, we can set up a proportion with this angle and this side across from it and solve for one or the other. That's what we're going to do. We're going to do an example of it. So in triangle QRS, side Q is 14, angle Q is 110, angle R is 20, and angle S is 50. We're going to find side R and side S. You'll notice that there are no 90-degree angles, which means we cannot use our SOHCAHTOA ratios. We just can't. To help us, I always like drawing some kind of triangle. It doesn't have to be drawn to scale, though if you can draw it, the more to scale, the better. For example, I want to have a 150 or 110-degree angle. And maybe have one thing being 20 and being 50. I can do that, but it's not necessary to help us set things up. So we can say that this is angle Q, which is 110 degrees. This will be our angle R, which is 20, and angle S is 50 degrees. Also says like side Q is 14. So tying back to what I've been talking about for a few years, including grade 9, the side Q has to be across from angle Q. So let's put our 14 there. It's just right across. Our sine law simply states that if we have the sine of an angle divided by the side across from it, it is going to equal the sine of an angle divided by the side across from that one. Well, we only have an angle, one angle and side across from it. So that's going to help us. So I'm just going to make that better. So the sine of 110 divided by 14 would equal a sine of, well, it doesn't really matter whether I solve for the 20 or solve for side R or solve for side S. Alphabetically, I'll solve for R before S. So sine of 20 divided by R. Then we use our cross multiplication. So sine of 110 multiplied by R. I usually like writing my variable in front. You can write it at the end. But it just allows me to say that, yeah, this is, actually I'll keep that in green. It just says that this is a side length. It's a number. It's not a variable. Well, it is right now. We're going to solve for the R, which means that then we're going to divide by the sine of 110. So R would be 14 multiplied by the sine of 20 divided by the sine of 110. Now, if you're typing that into your calculator properly, make sure, I know that on the Texas Instruments, when you type in sine, it opens up a bracket. Make sure you close it, especially before you divide. At the same time, make sure you are in degrees. If you're not in degrees, it's going to get a very wrong answer. So side R, this one, will be 5.1. If I want to solve for side S, I'm going to use, again, information that I have. I'm going to use this 110 and 14. So the sine of 110 over 14. One thing, actually, I'll write it down after I'm done this. The angle across from the side that I want is the 50. So the sine of 50 over S. We can set this up as being the reciprocal, which means that as long as you flip both sides, so B or sine of B, A over sine A, or you can just switch the two sides, it's still going to come out to be the same thing. So what I mean is I can write this like this. And we're still going to be correct. Biggest thing though, we're going to still have to do some cross multiplication. So cross multiplication there, cross multiplication there. Sine of 110 times S. So we have S multiplied by the sine of 110. I know that can be a little bit confusing, especially if you write SS and you might forget what your variable is. So that's another indicator that you need to be careful when you're working on your work. Solve for the S, I divide by my sine 110. And side S will be 14 divided by the sine of 50, or multiplied by the sine of 50, divided by the sine of 110. So 14, sine 50, and my bracket again, and I divide by the sine of 110. I get 11.4. So that's 5.1. That's 11.4. And I want you to pay attention to this. You notice it with right triangles. Well, it's going to be the exact same thing here. Our largest angle here of 110 is going to be across from the largest side. The smallest angle is obviously going to be across from the smallest side. The angle in between the two is going to have a value that's in between our largest and our smallest. That's another kind of visual check that you can do to make sure that you've done your things correctly. For example, if you don't have things in degrees, that would be one big indicator, though making sure that you're always in degrees is going to be an essential aspect of your calculations. Okay. We're not limited to solving for side lengths because we can also solve for angles. So if we want to determine an angle of an oblique triangle across from a known side, we just have to first know one side and an angle across from it. It's the exact same kind of information. Now it's sometimes known as the SSA property or side-side angle. We have a side, and an angle. So in this one, if we want to find out what is angle B, we're going to have to solve for it. I can put my variable on the left-hand side or on the right-hand side. It doesn't really matter. Actually, I'm going to put this as a red angle. Sine of B. The side across from it is 4.7. Then I'm going to use the information that I actually have. So the sine of 63 divided by 5.5. I have to do my cross multiplication still. Personally, I like keeping my variable on the left, just as you've kind of seen in this one. I like keeping my variable over on the left-hand side, which means I usually do this calculation first, whichever has the angle in it. So 5.5 multiplied by the sine of b is going to equal 4.7 multiplied by the sine of 63. I'm then going to have to divide by 5.5 to get the sine of b all by itself, because that b is directly, oh, sorry, not sine. That's directly attached to there. We can't get rid of it until we get rid of everything else attached to it. Dividing by the 5.5. So we do have the sine of b equal to 4.7 multiplied by the sine of 63 divided by the 5.5. And in order to get the b by itself, I'm going to have to get rid of the sine, which means I'm going to sine inverse. So those skills that we've been working on since grade 10 are not actually going to be gone. Sines cancel off. We're left with b equaling sine inverse of 4.7 multiplied by the sine of 63 divided by 5.5. Make sure that when you're working with this, you are able to calculate it out. If you can't calculate it out as we're working through examples, practice and make sure you make note of what you need to do in order to get that. If you need to add extra brackets, if you need to calculate one thing at a time, if you have to calculate everything on the inside first, get a decimal, and then take the sine inverse of that answer, you have to do whatever you need to do with your calculator. That's where the emphasis of having your own calculator that you are extremely efficient and proficient with is such a necessity. I get 46.9 degrees. And there's our sine law. Just making sure you always have the angle and a side across from it. Angle and a side across from it. Now you can have fun.